Welcome, everyone. Today, we're about to embark on a fascinating journey through history's greatest minds. Our presentation is titled, A Journey Through History's Greatest Minds. We'll explore some of the most influential scientists and their groundbreaking discoveries. So, get ready to learn about the brilliant individuals who changed our understanding of the world. Let's dive in. Let's talk about classical mechanics and a fundamental question that has intrigued humanity for centuries. Who discovered gravity? Well, when we ask this, the first name that often comes to mind is Isaac Newton. He's famously associated with understanding how gravity works, but it's interesting to consider that the story behind this discovery is quite fascinating. Newton didn't just stumble upon gravity overnight. His insights came from careful observation and groundbreaking thinking. So, when we think about classical mechanics, Newton's work laid the foundation for understanding the forces that govern the motion of objects on Earth and in space. This discovery is a key moment in science because it connects to the larger theme of how we understand the universe, using observation, reasoning, and mathematical principles. And that's why Newton's name is so closely linked to gravity. It's a cornerstone of classical physics that still influences us today. So, when we think about the question, who invented the light bulb? It's actually a bit more complex than it might seem at first glance. Many people often credit Thomas Alva Edison with inventing the light bulb, and in many ways, that's accurate. Edison didn't invent the very first electric light, but he did develop the first practical and long-lasting incandescent bulb. This invention was a huge leap forward because it made electric lighting accessible and reliable for everyday use. Edison's work was crucial because he improved upon earlier designs, making the technology commercially viable. His contributions didn't stop there. He also created the electrical systems needed to power these bulbs, which helped revolutionize how we live and work. So, when connecting this to our overall theme, Edison's story reminds us that innovation often involves building on previous ideas, refining them, and making them practical for everyone. His work exemplifies how perseverance and ingenuity can lead to inventions that change the world. Let's talk about radioactivity. Specifically, who discovered radium? The answer is Marie Curie and Pierre Curie. They played a crucial role in uncovering this fascinating aspect of atomic science. Their discovery not only advanced our understanding of radioactive elements, but also opened doors for numerous scientific and medical breakthroughs. It's important to remember that their work was groundbreaking and laid the foundation for future research in nuclear physics and medicine. So, when we think about the history of radioactivity, their names are certainly key figures to keep in mind. Now, let's talk about a major breakthrough in modern medicine. Who discovered penicillin? If you said Alexander Fleming, you're absolutely correct. Fleming's discovery revolutionized the way we treat bacterial infections. His work in the late 1920s showed that a mold called Penicillium notatum produced a substance that could kill bacteria. This discovery laid the foundation for the development of antibiotics, which have saved countless lives. It's a perfect example of how curiosity and observation can lead to life-saving innovations. As we continue exploring the history of medicine, remember that many of these discoveries are interconnected and have shaped the healthcare we rely on today. Let's talk about electromagnetism and its fascinating history. Who discovered electric current? Well, the answer is Michael Faraday. Faraday was a pioneering scientist whose experiments laid the groundwork for our understanding of electromagnetism. His work was crucial in demonstrating how electric currents can be generated and controlled, which ultimately led to the development of countless technologies we rely on today. As we continue exploring the connections between electricity and magnetism, remember that Faraday's discoveries were a key turning point in this field. His contributions really help us appreciate how interconnected these forces are and how they shape the modern world. So the question here is, who explained the structure of DNA? And the answer is Watson and Crick. They are actually credited with discovering the double helix structure of DNA, which was a groundbreaking moment in science. Their work built on the earlier research of scientists like Rosalind Franklin and Maurice Wilkins, but it was Watson and Crick who proposed the definitive model. This discovery was crucial because it helped us understand how genetic information is stored and passed on. It's a perfect example of scientific collaboration and ingenuity, which ties into the overall theme of how scientific breakthroughs shape our understanding of life itself. Let's talk about the telecommunications revolution, specifically the invention of the television. Now, when we ask who invented the television, the answer often points to John Logie Baird. Baird was a pioneer in early television technology, and his work laid the foundation for the visual communication we rely on today. His innovations helped transform the way we share information and entertainment across distances. Remember, this invention is a key milestone in the broader story of how technological advancements have shaped our connected world. When we look at the history of computing, it's fascinating to see how far we've come. And a key figure in this story is Charles Babbage, who is often called the father of the computer. He was a brilliant mathematician and engineer in the 19th century. Babbage designed the difference engine and the analytical engine, which are considered precursors to modern computers. His ideas laid the groundwork for the digital machines we use today. So, when asked who is known as the father of the computer, the answer is Charles Babbage. Recognizing his contributions helps us appreciate the evolution of technology and how innovative thinking can shape the future. Let's take a moment to look at the fascinating history behind the development of the smallpox vaccine. So, who is responsible for this groundbreaking achievement? The answer is Edward Jenner. Jenner was a pioneer in immunology, and his work laid the foundation for modern vaccines. His insight was to observe that milkmaids who had caught cowpox seemed immune to smallpox. Using this observation, he developed the first successful smallpox vaccine, which ultimately helped eradicate a deadly disease. This example highlights how curiosity and careful observation can lead to revolutionary advances in medicine. It also connects to our overall theme of how scientific discovery has transformed public health and saved countless lives. So, when it comes to discovering hydrogen, who should we really credit? Well, the answer is Henry Cavendish. He was a pioneering scientist who played a crucial role in identifying this element. Cavendish conducted experiments that revealed the existence of hydrogen as a distinct substance, separate from other gases known at the time. His work laid the foundation for understanding hydrogen's properties and its significance in chemistry. This discovery is a key part of the broader story of how we came to understand the building blocks of matter, which ties into the overall theme of scientific discovery and progress. So when asked, who proposed the theory of relativity? The clear answer is Albert Einstein. Einstein revolutionized our understanding of space, time, and gravity with his groundbreaking ideas. His theory of relativity fundamentally changed how we see the universe, showing that measurements of time and space are relative to the observer's motion. This concept is crucial because it challenged the long-held Newtonian view of an absolute universe. Throughout this presentation, we've seen how Einstein's insights have shaped modern physics, influencing everything from GPS technology to our understanding of black holes. So remember, Einstein's work is central to the scientific advancements we're discussing today. So when we talk about wireless communication, one of the most fascinating questions is, who invented the radio? It's a question that often sparks debate. And the answer? Well, it's Guglielmo Marconi. He's widely recognized as a pioneer in this field. Marconi's work in the late 19th and early 20th centuries really laid the foundation for modern wireless technology. His innovations allowed for the transmission of signals without the need for wires, transforming communication forever. This achievement connects to our broader theme of technological progress and how individual inventors have shaped our connected world. So, when you think about wireless communication today, remember that it all traces back to the groundbreaking efforts of people like Marconi. Now, let's talk about the fascinating world of medical imaging. Specifically, who discovered X-rays? This is a really important milestone in medical history. The answer is Wilhelm Röntgen. He was a German physicist who, quite unexpectedly, discovered a new form of radiation that could pass through the human body and produce images of bones and internal organs. This groundbreaking discovery revolutionized medicine by allowing doctors to see inside the body without surgery. It's a perfect example of how scientific curiosity and innovation can lead to technologies that save lives. So, in the context of our presentation, Röntgen's discovery laid the foundation for all modern medical imaging techniques we rely on today. So, let's talk about communication and one of the most revolutionary inventions in this field, the telephone. Now, you might wonder, who actually invented the telephone? Well, the answer is Alexander Graham Bell. He's the person credited with this incredible breakthrough that transformed the way we connect with each other. Bell's invention laid the foundation for modern communication, making it possible for people to speak to each other across long distances instantly. Throughout this presentation, we've seen how innovation and creativity push society forward, and Bell's work is a perfect example of that. His invention didn't just change communication, it changed the way we live and interact on a global scale. So, when it comes to the question of who discovered insulin, the answer is Frederick Banting. He was a Canadian scientist whose groundbreaking work in the early 1920s led to the discovery of this vital hormone. Banting's efforts, along with his team, revolutionized the treatment of diabetes, transforming it from a fatal disease into a manageable condition. This discovery is a perfect example of how scientific innovation can have a profound and lasting impact on human health, which ties back to our overall theme of medical breakthroughs and their role in improving lives. Thank you so much for being with me through this presentation. If you found this helpful, please like the video and subscribe to the channel. Your support helps me create more content like this. Remember, engaging with these lessons can really make a difference in your learning journey. So don't forget to like and subscribe, and I look forward to seeing you next time.